This is the OCR GCSE 9 to 1 Maths Paper 1 from the Foundation here, and it's from the June 2019 series, and it's a calculator paper. Question number 1. For part A, we have to write down the mathematical name of this polygon. Well, what you can see here is we've got 1, 2, 3, 4, 5, 6 sides, and therefore we have a hexagon. And of course you'd notice that the lengths are not all the same size, and therefore what we have is an irregular hexagon. And now for part B, we have to write down the order of rotation symmetry of the polygon. Well, if we draw the lines of symmetry, we have one around here, we have another one around here, and we have another one around here. And therefore, what you can see then is we have a rotation order of 3. For question 2, part A, we have to write down each of the following. For the first part, we want an odd number. Well, we can choose any odd number. For example, we can have 5. Of course, here 5 is an odd number. The second part, we have a factor of 25. Well, we can either choose anything from 1, 5 or 25. You'd find here these are the factors of 25. So we can choose either of these. We could, of course, have the 25. And the next one, we want a prime number between 20 and 30. Well, if you remember the definition of a prime number, that's a number that can be divided by 1 and itself only. So if we think about the prime numbers between 20 and 30, let's begin by writing the numbers between 20 and 30. We've got 21, 22, 23, 24, 25, 26, 27, 28 or 29. And the ones that are prime, we have 23, which is prime, and we also have 29, which is prime. So we can choose either of these to write down. We can of course write down 23, for example. And now for part B, we have to show that 55 is not a square number. Well, if 55 were to be a square number, that means the square root of 55 will give us a whole number. So if we work out the square root of 55, from our calculator, if we key in the square root of 55, you'd find the decimal equivalent is 7.416, etc. And what you can see here is this value is not a whole number, and therefore we can conclude that 55 is not a square number. Question number 3. We have to complete this table of fractions, decimals and percentages. Well, what you'd find over here, 1/4 is the same as 0.25 as a decimal. And on our calculator we can confirm this. If we key in 0.25, our calculator automatically shows the fraction 1/4. Next, we have to find the percentage equivalent of 7/100, which is the same as 0.07. Well, percentage means out of 100, and therefore we have here 7 out of 100, we have 7%. And we have to write down now for the final entry here the fraction equivalent of 1.3. Well, over here we can either do 130 divided by 100 and simplify that fraction to give us the correct value, or we can simply type in 1.3 into our calculator, and this gives us, in its simplest form, the fraction required. We have here 13 over 10. Question number 4. Here are the first 4 terms of a sequence. We've got 3, 8, 13 and 18. We have to write down the next term of the sequence. Well, what you can see here is, to go from the 3 to the 8, we have added 5. To go from the 8 to the 13, we have added 5. And to go from the 13 to the 18, we have added 5. And therefore, to find the next term, we'd have to add 5 to 18, giving us 23. So the next term of the sequence is 23. And then explaining our answer, all we did over here was add 5. And for part B, we have to explain why 534 is not a term in this sequence. Well, if we pay attention to the digits here, we see we've got a 3 and then an 8, and then this 13, it ends in a 3, and this 18 ends in an 8. This 23 ends in a 3. And therefore, what we can see here then is the terms in this sequence end with a 3 or an 8. So this number, 534, is not in the sequence. Question number 5. Lev, Maria and Nicholas sit in a row of 3 seats. For part A, we have to use the table to list all the different orders in which they could sit. One possible order is already down in the table. You do not need to use all the rows in the table. So in seat 1, so far we've got L, seat 2 we've got M, and seat 3 we've got N. What we could have done as well is have L, N and M in seats 1, 2 and 3 respectively. We could also have M, L and N in seats 1, 2 and 3 respectively, or we can have M, N and L in seats 1, 2 and 3 respectively, or we can have N, M, L in seats 1, 2 and 3 respectively, or we can have N, L and M in seats 1, 2 and 3 respectively. Now for part B, all possible orders in which they could sit are equally likely. What is the probability that Lev sits next to Maria? So we're looking for L being next to M. Well, L is next to M here. L is also next to M here. L is also next to M here. And L is also next to M here. And so therefore you can see we've got 4 out of a possible 6. So therefore this probability is equal to 4 out of 6, which is the same as 2/3. So we've got 2/3 as our required probability. Question number 6. For part A, we have to multiply out 4 lots of 3x plus 2. Well, here we've got 4 times by 3x, that gives us 12x, and then we have 4 times by 2, that gives us 8. So therefore, 4 lots of 3x plus 2 is equivalent to 12x plus 8. And now for part B, we have to factorize 3c minus 6d. Well, in terms of the numbers which are common to both 3c and 6d, we have a 3 common to both. And then you think to yourselves, 3 times by something gives me 3c. Of course here, that something is c. And we also think to ourselves, 3 times by something gives us minus 60. And of course here we would have minus 2d. So 3c minus 60 is equivalent to 3 lots of c minus 2d. Question number 7. A survey asked whether some students went swimming or played tennis last month. 17 students in total played tennis, 11 did not want to go swimming and did not play tennis, 22 went swimming, 8 went swimming and played tennis. Some of this information is shown on the Venn diagram below. And for this question we have to find out how many students were in the survey. Well, if we take each statement step at a time, we have 17 in total who played tennis. So this circle over here is equal to 17. And therefore, to find out the number of those who play tennis only, we have here 17 who play tennis in total, take away the 8 who also swim. And therefore, you can see here we've got 9 who play tennis only. We see that 22 students went swimming, and indeed this is confirmed by working out 14 plus 8. We see that 11 students did not want to go swimming and they did not play tennis. So we have 11 on the outside here. So for us to find out the total number of students in the survey, we have 11 plus 14 plus 8 plus 9. So if we work out this total, we've got 9 plus 8 plus 14 plus 11, which is 42. And therefore, there were 42 students in the survey. Question number 8. Kim is paid £9.40 per hour for the first 35 hours she works each week. After 35 hours, she is paid at 1.25 times the hourly rate. 1 week, Kim works 42 hours. We have to calculate how much Kim is paid for that week. Well, first of all, if she works 42 hours and her regular working hours are 35 hours, we can find out how many extra hours she is working. So the extra hours she is working, we have 42 take away 35, which is 7. So she works an extra 7 hours. She's paid £9.40 for the first 35 hours. And then she's paid 1.25 times the hourly rate for every hour over the 35 standard hours. Well, if we work out this new hourly rate, what we have here is £9.40 times by 1.25, which is the same as 1.25. So if we work this out, £9.40 times by £1.25, rather times by 1.25 hours, it turns out here we get £11.75. So for every hour over 35 hours, she gets paid £11.75. And therefore, she will be paid £9.40 times by the 35. So we've got the £9.40, which is the standard wage, times by the 35, which is how many hours she works. And then we add on the £11.75 multiplied by the 7 hours extra that she works. So if we work this out, we have £9.40 times 35 plus 11.75 times 7. It turns out here we get £411. and 25 pence. So we have £411 25 pence. Question number 9. Mike drinks 2/5 of a litre of juice each day. Juice costs £4.40 for a 2 litre carton and £2.60 for a 1 litre carton. Mike buys enough juice to last for 7 days. What's the lowest price he can pay for this juice? Show how you decide. Well, first of all, in 7 days, Mike drinks 7 multiplied by 2/5. So if we work this out, 7 times by 2/5 is 2.8. So in 7 days, he drinks 2.8 litres of juice. So if we think about the number of litres we need, we therefore need 2.8 litres every week. And if we think about how we can buy this, well, we can buy a 2 litre carton and we can also buy a 1 litre carton. So we need a 2 litre and a 1 litre carton. So we've got a 2 litre and a 1 litre carton required. And therefore, we would have 1 2 litre carton, so that costs us £4.40, plus 1 1 litre carton, so that costs us £2.60, and therefore the price of these added together is £7. So the lowest price he can pay is 7. Question number 10. Mr. and Mrs. Wilde have 5 children who are all different ages. The mean age is 6.4, the range is 9, the median is 6, the oldest child is 12. We have to work out the ages of the children, write their ages from youngest to oldest. Well, if the oldest child is 12, so we've got 12 here for the oldest child, we can use the range to help us find the age of the youngest child. So let's just say this box here would represent the youngest child. Well, let's just write all this down. We've got here the 12, which represents the oldest, and we've got this box which represents the youngest. The range, so the biggest age take away the smallest age, is equal to 9. So this 9 over here would represent the range. And therefore 12 take away something is 9. Of course that something is equal to 3. So the youngest child is equal to 3 years old. We also have the median being 6. Well, what we'll do is we'll write out the ages so far. We've got the youngest, who's 3, we've got the oldest, who's 12, and we've got the median, which is 6. So here, this would represent the median. And now we need to work out the other two ages. Well, we've been given that the mean age is 6.4. Now to work out the mean is equal to the sum of all their ages divided by n, and therefore the sum of their ages is equal to the mean multiplied by n, where n is the number of children we have. We have 5 children. So therefore the sum of their ages, we have the mean, which is 6.4. So here this mean would represent, the 6.4 would represent the mean, and we multiply this by 5, which is the number of children they have. So if we work this out, 6.4 times by 5, that's 32. So all of their ages added together gives 32, and for the remaining children, the remaining children would have an age of 32, take away 3, take away 6, take away 12, which is 11. So the other two children have their ages adding up to give 11, and therefore we need to find two numbers which add to give 11. We could have, for example, 4 and 7. So here, this 11 would represent the sum of their two ages. So therefore here we have a possible combination of their ages. Question number 11. We've got triangles A and B drawn on the coordinate grid, that's what we see here, and for part A we have to describe fully the single transformation that maps triangle A onto triangle B. Well, if we consider this line over here, and we'll point an arrow going upwards, you can see the corresponding point for this triangle B goes here. So what you can see then is, indeed we have a rotation by 90 degrees going clockwise, and if we think about what the center will be, well, of course we would rotate about the origin, because if we rotate about the origin then the points will match up, and you can try that out using tracing paper. And so therefore we have a rotation 90 degrees clockwise with center at the origin. And now for the first part of part B, we have to reflect triangle A in the line x equals 0. Well, the line x equals 0, that is this vertical line here, the y-axis. And so if we reflect shape A in this line, what we'd have is the following. We've got a shape with coordinates at -5, 2 up, then -2, 2, and then -2, 4, as we see here. So what we have here is shape C. And then we have to translate shape A by vector -5, -4. So if we pick any point, for example this point, we're going to go -4, so we're going to go 1, 2, 3, 4, 5 to the left, so that's that point. And then if we go 4 units down, we've got 1, 2, 3, 4. So therefore this point would correspond to this point, and then if we finish off the shape, we have something looking like this. So here we have the shape D. Question number 12. Jack and Alex take rubbish to be recycled. Jack takes 520 kilograms, 87% of which can be recycled. Alex takes 750 kilograms, 61% of which can be recycled. We have to calculate who takes the greatest amount of rubbish that can be recycled, and by how much. Well, if we consider Jack, then we need to work out 87% of 520 kilograms. This will tell us how much he is recycling. So we have 87%, so we've got 87 over 100 multiplied by 520. It turns out here we have 452.4 kilograms that needs to be recycled. And if we consider Alex, we have 61% of 750 kilograms. So here we've got 61 over 100 multiplied by 750. It turns out here we get 457.5 kilograms. So who has the greatest amount of rubbish that can be recycled? Well, clearly that will be Alex. And if we determine by how much, we have 457.5 take away 452.4, which is 5.1. So we've got Alex by 5.1 kilograms. Question number 13, we have to calculate the area of a circle with radius 14 centimeters. Well, to work out the area of a circle that's given by pi multiplied by the radius squared, and therefore for the area we have pi multiplied by 14 squared, because our radius is 14. So if we work this out, 14 squared, that's 196 pi. So therefore we've got 196 pi centimeters squared. You can write down the decimal equivalent. We've got 196 pi, which is 615.7, etc. You could have put that value down if you wanted to. Question number 14, for part A, the first part, we have to write down 356 to the nearest 10. Well, if we look at the 10 digits, the digit after, which is this 6, is 5 or greater, so this 5 we need to take up to the next value of 6, so we've got 360. And then we have to round 356.052 to one decimal place. Well, if we take a look at this first decimal place, after that this 5, well, we've got 5 or greater, so this 0 we need to take up to the next digit, so we have 356.1. For part B, for the first part, we have to find out the value of y with 3 times 3 times 3 times 3. Well, 3 is being multiplied by itself 4 times, and therefore we have 3 to the 4 equaling 3 to the y, and you can see then y is equal to 4. And then we've got 6 to the 3 times 6 to the 5 equals y. Well, when we have the same base number and we multiply, we would add the powers, as we see with this rule here. And therefore, we have 6 to the power of 6 to the power of 3 plus 5 equaling 6 to the power of y. So we've got 6 to the power of 8 equals 6 to the power of y, therefore y is equal to 8. Question number 15. Anna and Paddy take part in the same fun run. Anna completed the fun run in 2 hours. Her average speed was 6 kilometers per hour. Paddy completed the fun run in 90 minutes. We have to work out Paddy's average speed in kilometers per hour. Well, first of all, what you'd find over here is we've got minutes and here we've got hours, and we need to express our answer in kilometers per hour. First of all, to go from minutes to hours, we would have to divide by 60, and hours to minutes, we'd have to times by 60. And so therefore, if we convert the 90 minutes into hours, we'd have to do 90 divided by 60, which is 1.5. So 90 minutes is the same as 1.5 hours. How does this help us? Well, to work out Paddy's average speed, we need his distance that he travels, and we already know the time. Now, the way we can work out the distance is to consider Anna's run. We know already that speed is equal to distance divided by time. we need to find out the distance. So if we consider Anna, we can find the distance to equal speed, which is 6 kilometers per hour, multiplied by the time, which is 2 hours. Of course, we'd end up with 6 kilometers. And therefore, if we consider Paddy, the speed of Paddy, that's equal to the distance. Rather, here we've got the distance equaling 12. We've got 12 kilometers divided by the time, which is 1.5 hours. So we can find out the average speed would have 8 kilometers per hour. So therefore, we have 8 kilometers per hour. And now for part B, Anna says, because I stopped for drinks, my average running speed was faster than 6 kilometers per hour. Give one reason to support Anna's statement. Well, over here, the stopping time would have been counted as it's an average for the whole race. Question number 16. The volume of a piece of wood is 620 centimeters cubed. We've got a density of 0.85 grams per centimeters cubed. We have to work out its mass. Well, first of all, we should know that density is equal to mass over volume, and therefore mass is equal to density multiplied by volume. So therefore, if we work out the mass is equal to the density, which is 0.85 grams per centimeters cubed, multiplied by the volume, which is 620 centimeters cubed, and therefore 0.85 times by 620 is 527. So we have 527 grams for the density. Question number 17 for part A, we have to complete this table for y equals 4x minus 2. Well, what you can see here is we've been given different y values from 0 to 2, and then for 4. Now when x equals 3, we can find out what y is. We would have 4 lots of 3 minus 2, which is 10. So when x is 3, y is 10. And now for part B, we have to draw the graph of y equals 4x minus 2 between values of x from 0 to 4. So for part B, plotting these points and then joining up with the straight line, because we've got a linear graph, you can see here we've got y equals 4x minus 2. And then for part C, the diagram below shows part of another straight line, that's what we see here, and we have to find an equation for this straight line. Well, the equation of the straight line, that's of the form y equals mx plus c, and m here would represent the gradient, and c would represent the y-intercept. And if we take a look at what the y-intercept is, you can see the y-intercept is equal to 11, and if we calculate the, well, let's just mark this one. Here we've got the y-intercept, and if we find out the gradient is equal to the change in y of the change in x. And we can pick any 2 points, for example this one and this one, and if we work out the change in y, well, we're going from 8 to 5, so the change in y over here is equal to -3, and here we're going from 1 to 2, so the change in x is equal to 1, and therefore the gradient that's equal to change in y, which is -3, over change in x, which is 1, so the gradient is -3, and therefore what we have for our equation of the straight line, we've got y equals -3x plus 11, where the -3 was the gradient and the 11 was the y-intercept. Question number 18, here is a right-angled triangle. We've got side lengths of 12 centimeters, 18 centimeters, and x centimeters. We have to work out the value of x. Well, if we use Pythagoras, x squared is equal to 12 squared plus 18 squared. So therefore, if we work out what x squared is, we would have 12 squared plus 18 squared, which is 468. And therefore, if we work out what x is, we need to square root the 468. So square rooting this value, we get 6 root 13. And if you want to write this down as its decimal equivalent, we end up with a value of 21.6 given to one decimal place. Question number 19 for part A. Anne, Barry and Colin share a prize in the ratio 3:45. Colin gives a third of his share to charity. What fraction of the whole prize does Colin give to charity? Well, if we consider Colin, the fraction that Colin has is 5 over 3 plus 4 plus 5. So if we work this out, we've got 5/12. So Colin has 5/12 of the prize. And therefore the amount he gives to charity is a third of this. So we've got 1/3 of the 5/12. So if we work this out, we've got 1/3 multiplied by 5/12, which is 5 over 36. So we end up with 5 over 36 as our fraction. And then for part B, Delia, Edwin and Freya share some money in the ratio 5:7 to 8. Freya's share is £1,600. How much money did they share? Well, D to E to F, that's equal to 5:7 to 8. And we know that F has 1,600. To go from 8 to the 1,600, we need to multiply by 200. So multiplying each of these by 200, 5 times 200, that's 1,000. 7 times by 200, that's 1,400. And therefore, the total, we've got 1,000 plus 1,400 plus 1,600. It turns out here, we get 4,000. So the total they've got is 4,000. Question number 20. Luke is an office receptionist. Each day for 60 days he records the number of people visiting the office. So we've got the number of people and the frequency, and for part A we have to calculate an estimate for the mean number of people visiting the office. Well, for a grouped frequency table, if we wish to find the mean from that, first thing we can do is find out the midpoints of each of these intervals. Here the midpoint of 0 and 5, that's 2.5. Here we've got 7.5. Here we've got 15. And here we've got 30. So we found the midpoints of each of these intervals. And then we need to do the frequency multiplied by the midpoint, 20. If we work this out over here, we have 20 times by 2.5, that's 50. 14 times by 7.5, that's 105. 11 times by 15, that's 165. 15 times by 30, that's 450. So therefore, to work out the mean, we need over here the mean is given by the sum of the frequencies times by the midpoints divided by the sum of the frequencies. So if we work this out, we've got here 50 plus 105 plus 165 plus 450 divided by the sum of the frequencies, which is 60. We've got 60 people who visit the office. So if we work all of this out, we have 50 plus 105 plus 165 plus 450 divided by 60. And so therefore here we end up with a value of 12.83, etc. So therefore for the mean number of people, we'd have approximately 13 people. And now for part B, Luke says the range is 40. Explain why he might be wrong. Well, if we go back here, what we're saying with the number of people being in between 20 and 40, we can have values up to and including 40. So the highest number could be less than this, but we don't know for certain, and the lowest number could be greater or equal to 0, we don't know. So therefore we could have a smaller range. So the highest number of people may not have been 40, or the lowest number of people may not have been 0. Question number 21. James and Elizabeth buy some clothes. James buys 5 shirts and 4 jumpers. He pays £163. Elizabeth buys 3 shirts and 2 jumpers. She pays £89. Assume that each shirt has the same cost and that each jumper has the same cost. We have to work out the cost of one shirt and the cost of one jumper. You must show your working. Well, if we consider what James is doing, we have here 5 shirts. So we've got 5S. And then he also buys 4 jumpers. So we've got 5S plus 4J, and in total we get 163. And if we consider Elizabeth, well, she's buying 3 shirts and 2 jumpers, and she's paying £89. We need to find out the cost of 1 shirt and 1 jumper. Well, here you can see we've got 2 unknowns and 2 equations, so we'd have to solve these equations simultaneously. If we call this first one equation 1 and this equation 2, what we can do is multiply this equation by 2, and if we do that, we have 6s plus 4j equals 89 times by 2, which is 178. We'll call this equation 3. And if we can look at equation 1 and 3, the number of j's is the same. So what we can now do is do equation 3, take away equation 1. And if we do that, 6s take away 5s, well that's just s. 4j take away 4j, that's 0j. 178 take away 63, you'd find that to be 15. So s is equal to 15, and when s is equal to 15, we can find out what j is. So here we'd have 3 lots of 15 plus 2j equals 89. 45 plus 2j equals 89, and if I subtract off 45 from both sides, 89 take away 45, that's 44. So we've got 2j equals 44, and therefore j is equal to 22. So the cost of 1 shirt is £15, the cost of 1 jumper is £22. Question 22. Claudia invests £25,000 at an interest rate of 2% per year compound interest. We have to calculate the total amount of interest she will have earned after 5 years. Give your answer correct to the nearest penny. Well, we've got our original amount, 25,000, so this here is the original amount of money we have. And then we're investing at a rate of 2% per year, so we multiply by 1.02. So this comes from the fact that we're investing at a rate of 2% per year. And then we raise this to the power of 5, because we're looking at 5 years. And what we can do is find out the total amount of money we have after 5 years. We've got 25,000 multiplied by 1.02 to the power of 5. It turns out here we get 27602.02. So this is the total amount of money she has after 5 years, and therefore for the interest we'd have 27602.02 take away 25,000. So here we get 2602.02, as we see here. So we've got 2602.02. 2. Question 23. A bus timetable shows the following information. A bus route leaves T for the train station every 20 minutes. A bus following route A leaves for the airport every 18 minutes. A bus following route T and a bus following route A both leave at 8:37 a.m. When is the next time one of each bus is timetabled to leave at the same time? Well, here we'd have to find out the lowest common multiple of 18 and 20. That tells us after how many minutes to leave at the same time, and then we add this to the 8:37. So if we consider the route T, we start off by listing the multiples of 20. So if we've got 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. We can continue if you wanted to. And if we consider route A, if we list the multiples of 18, we've got 18, 36, 54, 108, 126, 144, 162, 180, 198, and 216, and we can continue. And what you'd find over here is 180 is the lowest common multiple. So therefore, we have 8:37 a.m. plus the 180 minutes. Well, to go from minutes to hours, we can divide by 60, and hours to minutes, we times by 60. And therefore, if we divide 180 by 3, we get, rather if we divide 180 by 60, we get 3. So therefore, we've got 8:37 a.m. plus 3 hours. It turns out here we get 11:37 a.m. So we have 11:37 a.m. for the time when they both next leave at the same time. And now for part B, we have to write down one assumption that was necessary to solve this problem. Well, we've assumed over here that there's no delays. In other words, everything comes at the same time. Question 24. AOB is a sector of a circle with centre O. We see here we've got 50 degrees and our radius is 6 centimeters. We have to show that the arc length of AB is 5.24, correct to 3 significant figures. Well, to do this, to work out the circumference of a circle, we've got 2 pi r. So the 2 pi r tells us how to work out the circumference. But the problem is here we don't have a full circle. Instead we've got a portion of a circle, and therefore you'll find the arc length to equal theta over 360 multiplied by 2 pi r. So if we work this out, we have 50 over 360 times by 2 times by pi times by 6, and if we work this out, we have 50 over 360 times 2 pi times by 6. It turns out here we get 5.23598, etc. And if we round this to 3 significant figures, indeed we get 5.24 centimeters given to 3 significant figures. Question 25. Benny is 7 years older than Aisha. Chloe is twice as old as Benny. The sum of their 3 ages is 57, and we have to work out the ages of Aisha, Benny, and Chloe. Well, we begin by letting Aisha's age equal x, and if we do that, then Benny's age, if Benny is 7 years older than Aisha, then Benny's age is x plus 7. And Chloe is twice as old as Benny, so therefore Chloe's age is twice the x plus 7. And what we were told is that the sum of their ages is 57. So we've got x for Aisha plus x plus 7 for Benny plus 2 lots of x plus 7 for Chloe. We get a total of 57. So we've got x plus 2 times by x, so that's 4x. So we've got 4x plus 7 times 7 plus 14, so that's 21. This is equal to 57. And therefore, if we take 21 from both sides, you'd find 4x to equal 36, and therefore x is equal to 9. So that means Aisha's age is 9, Benny is 7 years older than Aisha, so 7 plus 9, that's 16, and Chloe is twice as old as Benny, so here we've got 32 for Chloe. So that's the end of the paper. I hope you found this video useful. Don't forget to like, comment, and subscribe. Hopefully I'll see you on the next video.